All right, hopefully everyone had a nice exam. We are now into the second chunk of the class. We're going to be talking about derivatives today. Again, we're going to be talking about derivatives for a lot of this class in calculus, so let's get right into it. So recall that f prime of x, one way of writing this is the derivative with respect to x of f of x, d dx notation, all right? This is derivative with respect to x, are what those two things mean. All right, but there's other ways of writing this because f, we can also call f y. And in fact, we do it very frequently. So if we do that, of course, we also can write it dy dx. We've seen this before. However, what we haven't seen before is that this works for other variables, right? This x down here is just what are we taking the derivative with respect to? And this y up here is just the function name. So we can change those letters, no problem. So this works for other variables as well. And that's what we're going to be talking about in this first video. So example 1, let's compute some derivatives with other letters. Compute. Nope, that's not a colon. That looks like a weird liney thing. Part A is going to be find ds dp. All right. For s equals 3 times p squared plus 5p plus 1 to the 10th. All right, so this is just taking the derivative with the general power rule exactly like the previous section. It's just different letters. So we want to take the derivative of s with respect to p. So p is the variable. We will take ddp of both sides to get that ds dp is equal to the derivative of this. So remember, with our constant multiple rule, this 3 comes out in front. And then we have to take the derivative with respect to p of what's left over. And this is where the general power rule is going to come in. All right. So we have a function raised to an exponent. So that exponent's going to come down. We're going to subtract an exponent and then multiply by the derivative of the inside function. All right. So the 3 is still out in front like before. That 10 comes down. The inside always stays the same. Remember this inside right here. A lot of times we'll call this, f of x or something like that. So that doesn't change. The general power rule says that we do have to subtract 1 from the exponent. So now there's only a 9 up top. But we have to multiply by the derivative of this inside. Multiply by the derivative of that f. So derivative of that is going to be 2p plus 5 plus 0. All right, so we're basically already done. We can simplify a little bit. 3 times 10 is 30. We'll usually write that binomial in front. Binomial, remember, is the thing with 2 terms. And then we'll have the other thing at the end. All right, so very little is new. It's just notation. All right. We're taking the derivative with a different variable. And this is what that means. The derivative of s with respect to p. All right, we got 2 more examples showing other notations and other things that can kind of appear or happen. And then we'll move on to the next video. So let's take the derivative with respect to t. So t is the variable here of at squared plus capital S times t to the negative first power plus capital S squared. And here the note is that a and s are constants. You got to be a little careful here because there's a lot of letters, but you're not taking the derivative of all the letters. The letters are just numbers. So anything that's not a t is a number. So what's this going to look like? Well, a, that's a number. That's going to come out in front. But then we'll take the derivative with respect to t of t squared. Plus s, that's a number. That'll come out in front of the derivative. times the derivative with respect to t of 1 over t, or t to the negative 1, plus, be very careful, there's no t's here. There's no t's here. That means that's a constant, right? Whoa. Since that's a constant, the derivative of a constant is 0. Whoa, hey, let's be red. Let's be white. All right, so let's simplify this. Derivative of t squared is 2t. We have 2at. And then this negative 1 comes down and we subtract 1. So it becomes minus s times t to the negative 2. Exponent gets lowered by 1. And that's our derivative right here. Okay, so that's all there is to it. One more piece of notation, we'll be good to go. So dy dx evaluated at x equals a is the same thing as f prime at a. So again, just different notations here. This right here is the derivative, and this vertical bar means we evaluate it at x equals a. All right, so let's get going and use that with example 2. And so here, s is going to equal t cubed minus 2t squared plus 3t. And the question is, I want you to find ds dt, so the derivative of s with respect to t, evaluated at t equals negative 2. So we'll just take the derivative like normal and then plug in negative 2 at the end. All right. So ds dt, we'll take the derivative with respect to t to get ds dt is equal to 3t squared by the power rule minus 4t by the power rule plus 3, you guessed it, sorted by the power rule. Or you can think of 3t as a line, and the slope of a line is going to be that 3. All right. And specifically, we want it to be evaluated when t is negative 2. So we'll have, all right, ds dt. It's not really going to fit here. ds dt is going to be evaluated at t equals negative 2. So we're just plugging in negative 2 into what we had before. So it's 3 times negative 2 squared. Be very careful to include parentheses. These are important parentheses, otherwise you're going to get the wrong answer. All right. And then minus 4 times t, which is negative 2, plus 3. Like so. All right. So we just simplify, plug that into a calculator, and you can get 3 times 4 is 12. Negative 4, that's going to be plus 8. Plus 3 should get 23, unless I made a silly mistake, which happens. In which case, you can comment on the video at the specific timestamp and say, hey, isn't this supposed to be 24? And I'll look at it and say, yes, you're right. Good catch. All right. So, yeah, there we go. That's the first video. Good luck.